We'll worry about that maybe a little later. So in section 4.2, we're going to be talking about problem solving. What we really mean there is really kind of dealing with story problems. So that's going to be kind of the theme here. I'm just opening up the lesson so I can copy and paste the story problems in here. Before we do that, though, we should define a couple of terms that'll be important as we'll use them inside of these story problems. And if you're unable to, or if you don't know what these terms really mean, you'll really have a hard time drawing the correct picture, and then that makes the solving near impossible, right, if you're not able to draw the correct picture. So there's two terms, and I'm just going to kind of describe these visually. So I'm not going to necessarily try to write these out in words because it's not super duper practical. So the first one is called an angle of elevation. So imagine you're standing on the ground and you see like an airplane going by in the sky or something. I mean, it's not my best airplane, but it's like respectable. You can tell what it is. At least when I say an airplane, you're like, okay. Sure, that can be an airplane. So when we talk about an angle of elevation, we're thinking about the person as like a line of sight. That's if they're looking straight ahead. And then if they look up at the airplane, that angle from their line of sight rotated up to the thing they're looking at in the sky is an angle of elevation. Hi. I know. Thanks, dude. Everybody feel okay about the angle of elevation here? The key thing to remember is that you're always starting at the line of sight and then rotating towards that object. The other one is called an angle of depression, and we call it that not because it's like sad. So imagine now you're standing like at this elevated position and you see your friend down on the ground. So when we talk about an angle of depression, again, we're always starting from our line of sight. And then if you tilt your head down to see your friend, the angle formed there is an angle of depression. Oh, thank you. So basically when we talk about angle of elevation or angle of depression, angles of depression are happening below our line of sight, and angles of elevation are happening like above our line of sight. Lexi? Yeah. Yep. Regardless of whether you're talking about an angle of elevation or angle of depression, the angle's initial side is that line of sight, and then the terminal side is whatever way you're kind of rotating. Okay with that? So we'll do some story problems here. And I'm just going to, rather than writing these down, I'm just going to steal them out of our book here. Because it's just frankly easier. All right. Christy is looking up at the Fisher Building in downtown Detroit. She is standing 200 feet from the base of the building and finds the angle of elevation to the top of the spire to measure 66 degrees. And then we want to know how tall is the Fisher Building. So we'll start by drawing a picture. Hopefully we're not surprised at that. So here's Christy. Here's our Fisher Building. So we have our line of sight. And we're looking up. So what kind of an angle is that? That's an angle of elevation. And we're told that we are 200 feet from the building. And we want to know how tall the building is. So we're looking for that. Hopefully, this doesn't take a lot of imagination to see that this is just turns into like a right triangle. Everybody can see that? So if I want to solve for this side h in this right triangle, which trig function am I going to want to use? Not the Pythagorean theorem. Relative to the angle that I know, the two sides I know are opposite and adjacent, so I should pick tangent. So I can say tan of 66 is going to equal opposite over adjacent. And now I'm just going to solve this equation for h. To solve this equation for h, what would I want to do first? Multiply both sides by 200. So I'd have 200 times tan of 66 is equal to h. And at that point, it's now calculator time. Before I try to type this into my calculator, though, what should I check? I should check the mode. What mode should our calculator be in for this problem? Should be in degree mode because we measured our angle in degrees. I'll start by changing my calculator to degree mode. And then we'll do 200 times tan 66. And when I do that, I get 449.21 feet. Everybody okay there? All right. We'll look at the next example here. Here it says, Jane has climbed a tree and is looking down at her friend Mary. Jane has climbed 17 feet in the air, and the angle of depression to Mary is 49 degrees. And we're asked, how far is Mary standing from the base of the tree? Okay. So I'm going to start by drawing a picture. So here's our friend Jane up in the tree. There's her line of sight. And down on the ground is her friend Mary. That's not very good. So we're told that this angle of depression is 49 degrees. We're told the height of the tree is 17 feet. Okay. Now, if I look here, I have like this right triangle here, correct? The problem is that 49-degree angle isn't part of that right triangle that I've just drawn. However, I remember a theorem from geometry that can help me here. I know that the line of sight and the ground should be parallel, right? Everybody agree with that? That makes the hypotenuse of this triangle like a transversal. So if I have two parallel lines cut by a transversal, this angle here and this angle down here are alternate interior angles. So I know that that angle is also 49 degrees. Do you remember alternate interior angles? They're just congruent. So if you have two parallel lines cut by a transversal, we say that alternate interior angles are these guys, and those guys are congruent. Does that start ringing a bell? I know geometry was a long time ago. Yeah. Well, it's going to be the angle you know something about. Yeah, so if we draw this into a triangle now, we're going to start with the angle that we know something about. And then relative to that angle, the 17 is opposite, adjacent, or hypotenuse. Opposite. And the x is adjacent, so the trig function I need then is tangent. So it's all based on the angle that you're looking at. So we can write the equation tan 49 is equal to 17 over x. What should I do first to solve this equation? I wouldn't do that. I would do the same thing we did before and multiply both sides by x, by the denominator of the fraction. If we divide by 17, you're going to be left with 1 over x, which is not the same thing as solving for x. And now that we have x times tan 49, what should we do? Divide by tan 49. And then it's calculator time. Yep. So if you change your calculator to degree mode previously, it should still be there in degree mode now. So you don't need to check every time. You just need to check kind of when you start doing the problem. Yeah. Well, depends on the angle measurement that you're given. Right? These angles that we've been talking about so far have all been measured in degrees. That's how you know it should be in degree mode. If the angle was described in radians, you'd use radian mode. Like if it was like pi over 6 angle of depression or something, you'd know to use radians because that's a radian measure. You're welcome. Everybody okay with this one? These are feet. Sorry. You're right. Thank you. Our next example, and this is probably as complicated as we'll get here, is something like this. So here we have Claude and Simone are riding bicycles in Paris. At one point, they look up and measure the angle of elevation to the top of the Eiffel Tower to be 32 degrees. When they pedal 100 meters closer to the tower, the angle of elevation changes to 37.5 degrees. How tall do they estimate the Eiffel Tower to be? So again, I'm going to start by drawing a picture. So we have, our people on our bicycle here. And then we have the Eiffel Tower. So the first time we do this, it's 32 degrees. And then we pedal a little bit closer. And when we look now, it's 37.5 degrees. And we're told that this distance here is 100 meters. Everybody okay with the picture that I've drawn? That looks like what was described there in words, right? So just like before, I'm going to start by turning this just into a right triangle situation. So this is the information that we know. Everybody agree with that? So when I look at this is the tricky part, is that there are actually two right triangles in this picture. Right? There's this right triangle here, and then there's this right triangle here. Everybody can see that? So as I've currently drawn this picture and labeled this picture, do we know two sides of either of these right triangles? No. So what I'm going to do is, what? There's the green one and the purple one. So what I'm going to do is I'm going to label this side of the green right triangle as X, which means that this side of the purple right triangle would be X plus 100. So if I then redraw these two separately, just so it's a little bit easier to kind of see what's going on. We have those two separate right triangles. Everybody feels okay with that. Notice still here, in either situation, I have two unknowns on my sides, right? So what I'm going to end up doing here is I'm going to form a system of two equations because I really have two variables. I have x and I have h. So in this first triangle, if I focus on the 37.5 degree angle, I want to know about the opposite and the adjacent, so I'm going to use tangent and similarly in this right triangle I know about the 32 degree angle, so this is opposite and this is adjacent, so I will also use tangent. Everybody so far so good? If I put these together now, I'm going to have this system of equations that I want to solve. So what are some of the methods we had for solving a system of two equations that you guys learned last year in your algebra course? So there would have been two primary algebraic methods that we would have talked about: substitution and elimination. Hopefully those names sound familiar at least. Of those two methods, which one would be the more appropriate method in this case? I would actually be using substitution here. And the reason that I would use substitution here is because unlike the kinds of problems that we solved in our Algebra 3-4 class last year, here I have like variables that are being multiplied or divided to one another. It's much easier to solve a system like that using substitution than elimination. Okay with that idea? So my first step is going to be rewriting these equations so that they're not fractional anymore. So I'm going to start by multiplying the first equation. I'm going to multiply both sides by x. And the second equation, I'm going to multiply both sides by x plus 100. Now we're ready to make a substitution. So what are we going to substitute? Notice both of these equations are just equal to h, right? So what can I say then? I can say that their left-hand sides are going to be equal, right? If they're both equal to h, they must be equal to each other. Everybody okay with the substitution that I made there? Not a too bad a one, right? That's pretty, hopefully it was pretty obvious. Okay. What I need to do now is solve for x. That's going to involve getting the x's onto the same side. So to do that, I would need to distribute here on the right-hand side. Everybody's okay there? Now I'm going to subtract x tan 32 from both sides so that I can move the x's both onto the left-hand side of the equation. Everyone okay there? Notice now on the left-hand side, each of the terms on the left-hand side contains a factor of x. Right, I have x tan 37.5 and x tan 32. What I'm going to do now is I'm going to factor a greatest common factor of x on the left-hand side. So that's going to be x times the quantity tan 37.5 minus tan 32. I need to do that because that's going to get me x in just one place. So now if I divide both sides by tan 37.5 minus tan 32, I'd have the x isolated. And here, it's now calculator time. So I have, use the fraction command to do this, 100 times tan 32 divided by tan 37.5 minus tan 32. When I do that, I get 438.64. But what was this question actually asking us to solve for? The h, right? But that's okay. Once we have this x, it's going to be really easy for us to solve for h. All I need to do is go back to one of these two equations and plug in my result for x, and that'll get me my h. So I'm going to do it for the first one here. So I'm going to do that x times tan of 37.5. So the height is going to be 336.58. Everybody okay with that? This is by far the worst or most complicated of these kinds of problems that you're going to see. And the part that really makes it difficult is having to solve that system. Okay. We'll stop here for today.